Bismillah ar-Rahman ar-Rahim. How are you today? I hope you're feeling good. My name is Rawa'a here. Today I will talk about in my presentation about ionophore toxicity. I hope you will like it. So let's get begin. Let's get begin. Ionophore are chemical species that reversibly bind ions, cations, that mean ions have positive charge. Many ionophore are soluble liquid entities that transport ion across cell membrane in the absence of protein. This can disrupt the membrane potential, and these substances could exhibit cytotoxic properties. Ionophore are used as coccidiostasis and growth stimulus in certain types of livestock feed. I want to talk a little bit in coccidiostasis. Coccidiostasis are used for the treatment and prevention coccidiosis, which is contagious amoebic diseases affecting livestock, particularly poultry. So, presently, 7 carboxylic ionophores are marked for use as anticoccidial drugs for poultry and growth hormone in ruminant. These ionophores include monensin, lazalocoid, salinomycin, narazine, madrinomycin, ladlomycin, and simiduromycin. Now I will talk about the structures of ionophore. Many ionophore are liquid soluble and transport ions across hydrophobic membranes. When we talk about hydrophobic membranes, I mean surface or molecules repel water, so it's non-polar. These hydrophobic membranes, such as liquid bilayer found in the living cells or liquid polymeric membranes. So, structurally, an ionophore contains a hydrophilic centers and hydrophobic portions. These hydrophobic portions interacts with the membrane. Ionophore ions are bound to the hydrophilic centers and form an ionophore ion complexes. Now, types of ionophore ions transport, in the other words, classifications of ionophore according the size of ions that transport across biological membrane. The first one is mobile ion carriers that bind to a particular ions, protecting its charge from the environment around it. I mean hydrophobic membrane, thus facilitating its passage into the hydrophobic interior of the lipid membrane. In this case, we lose the capacity to transport ions under conditions of very low temperatures. Other types is channels formers, acting by introducing a hydrophilic pore, here a pore, hydrophobic pore into the membrane, allowing the ion to passes, avoiding connecting with hydrophobic interior with the membrane. Also, they can maintain their ion transport capacity even in low temperatures. So even in low temperatures. So the goal of the ion carriers is to protecting the ion forming from the external environment, which is hydrophobic, since the ion is attached to the hydrophilic portions. There is an important information to know is this transport occurs by facilitating transport. I mean down of concentrations from the high concentrations of ions to the low concentrations of ion. Now I will talk about the mechanisms of ionophore. The mechanisms of ionophore here in pictures A illustrated small ionophores, I mean ion carrier. Bind with ion, this ion carrier bind with ion, here ions, shield it from lipophilic, I mean hydrophobic membrane, interior of membrane, and transport it to other sides of membrane, here illustrated here. In the pictures B, illustrated large ionophores form, I mean ions channel across the membrane and transport ion through these channels, and here is ion because these channels have a hydrophilic interior which assists to transport ions, while its hydrophilic lipophilic exterior shield ions from interior of membrane. Now I will talk a little bit in details about the third types. The third types of ionophore is polyether ionophore. There are three mechanisms of cation transport by polyether ionophore due to their lipophilic surface and polar interior core containing oxygen atoms and one carboxylic group. So the polyether ionophore are suitable to transport metal cations across lipid membranes. The first type mechanisms is electron neutral. Here is electron neutral. The metal cation is incorporated into the polyether skeleton. I mean pseudocyclic skeleton structures of ionophore, and diffuses to another interface where deprotonated ionophore anion, which is COO negative, binds with H positive to release positive, I mean metal cations. Other mechanisms is electrogenic. Electrogenic is bind and transported by ionophore acid molecule forming COOH and positive complexes such here. Now I will talk about the last mechanisms is biomimetic transport can be releasing by polyether ionophores with modified carboxylic groups such as amides and esters. Here are that mean amides or esters. Here are amides or esters. Now I will talk about ionophore in horses. Horses are much more susceptible to ionophore toxicity than other species of animal, of course. Not all ionophore exposures are necessarily dangerous in horse. The risk depends on the amount of ingested. The horses might be developed only transit anorexia and nothing more serious. There is nothing more serious. However, if the horses ingested several pounds of feeding containing very large amount of monensin, that means containing large amount of monensins, this easily causes die. Ionophore toxicity in horses involves ionophore antibiotics. They are that are added to the feed cattle, swine, goats, and poultry for preventing growth and controlling coccidiosis. Horses that come into contact with feed that has ionophore additives can become extremely ill and possible even to die, so because it has a ionophore toxicity. Now I will talk about the clinical things of ionophore poisoning in horse, very depending on the dosage ingested, such as poor appetite, feed refusal of the grain products, diarrhea, weaknesses, rapid heart rate, colic, wobbly gait, sweating, and sudden death. Finally, there is no antidote for ionophore poisoning, but veterinaries can entities symptomatic and supportive care. So some horses may be die and other may be recovered over day. Thank you very much for listening to me.